Ah, my favorite word problems. Okay. Mo has $50 in savings and earns $5 per week delivering papers. Larry has $20 in savings and earns $10 per week doing yard work. Find the time in weeks when Mo and Larry will have the same amount of money in their savings account using algebra. Let X be the number of weeks and Y the total money. Okay, so Mo, his total money, which is Y, is he's got 50 bucks. And then he's earning $5 a week. And we said X is weeks. Larry has $20 in savings and is earning $10 per week. The question asks, when will they have the same amount of money and how much is it? So this is amount of money. We want to know when the Y's are the same, when the money's the same. So that means I can just set them equal to one another. When are the values equal? All right, well, let's see. If I subtract 5x from both sides, this becomes 5x. If I subtract 20 from both sides, that becomes 30. So x is 6. And we said above that x was number of weeks. So we've got in 6 weeks. All right, and then how much is it? Well, y is how much money Larry has. So if we just plugged in 6 here, I get 20 plus 60, and that is going to be $80. Okay. All right, next question. A sea lion swims 8 kilometers from one feeding ground to another in 27 minutes. The return trip against the ocean current takes 36 minutes. How fast does a sea lion swim in still water? So these are in minutes, and we want our answer typically in kilometers per hour. So let's see, when we set up our table for distance, rate, and time, we need to convert these minutes into a fraction of an hour. So we have with the current and against, all right, versus. We have rate times time is equal to distance. It's a D. So with the current, we're going to call C current and R the sea lion's rate. So with the current is R plus C. Against the current is his rate minus the current. The time, well, this is with the current. So it takes 27 minutes, 27 over 60 of an hour. And the distance is 8 kilometers. And the return trip against the ocean current takes 36 minutes. So our time is 36 over 60. And it's the same distance. So we have enough information for 2 equations here. 27 over 60. If I divide those both by 3, this becomes 9/20ths. I have time times rate is equal to 18. Okay, the rate times the time is equal to 18. The rate times the time, if I divide those both by 6, actually, let's divide them both by 12. I get 3/5. And that is equal to 18. So I have 2 really ugly equations with fractions, but I can clear these fractions. Okay, if I multiply this by 20 over 9, this just becomes R plus C. And if I multiply this side by 20 over 9, I have to do the same thing over here. Well, 9 goes into 18 2 times. 2 times 20 is 40. So I just turned this really ugly equation into R plus C equals 40. Here, I need to get rid of 3/5, so I'm going to multiply by 5/3. Multiply 18 by 5/3. 18 divided by 3 is 6, times 5 is 30. And this is R minus C. Now this is extremely easy to solve. I'm going to go ahead and add to get rid of the C's. So add those, I get 2R. Add those, I get 70. So the rate of the sea lion is 35 kilometers per hour. The question was how fast a sea lion swims to water. That is what our answer is. If we wanted to know the current, we know that the rate plus the current is 40, so the current would have been 5 if we needed that. But this is what we needed. Okay. Steve flew his experimental plane 56.25 kilometers with the wind in 45 minutes. Return trip took 75 minutes with no change in the wind. Okay, so rate times time is equal to distance. So we have with and against. So I'm going to say air, and we'll go P is the plane. Okay, or we'll call W wind. Doesn't really matter. So with the wind, we have the plane speed plus the wind. Against the wind is the plane speed minus the wind. The time, again, this is in minutes, so we have to do fraction of an hour. So we have 45 over 60. We flew 56.25 kilometers. The time against the wind, it took 75 minutes. Again, same distance. All right. I like to reduce these fractions. This is 3/4. Divide those by 15. This is 5/4. All right. So we know that 3/4 times P plus W is equal to 56.25, right? Here's the time times the rate is equal to 56.25. We have the time times the rate. Okay. Again, I don't like working with, I don't want to distribute and have some really ugly fractions, so I'm going to multiply this by 4/3. So I multiply this by 4/3. So if we take 56.25 times 4 divided by 3, I get 75. So this went away. I have P plus W is equal to 75. Okay. If I multiply this by 4/5, multiply this by 4/5, 56.25 times 4 divided by 5, I get 45. And that's P minus W. All right. So let's go ahead and add these. We can get rid of, actually, no, we want the wind speed. So let's subtract. So P minus P goes away. W minus a negative W is 2W. 75 minus 45 is 30. So the wind speed is 15 kilometers per hour. Okay. Alrighty. 2 more. During the year, Charlie read 5 more books than twice the number of books than Frankie. Okay. If together they read a total of 29 books, how many books did each read? Okay. So we have Charlie and Frankie. So Charlie, he read 5 more books than twice the number of books Frankie read. Right? 5 more than twice the number of Frankie. Together, they read a total of 29 books. So that means Charlie plus Frankie read 29 books. Ooh, this is nicely set up for substitution. So if C is 2F plus 5, I can just substitute 2F plus 5 where I see C. So this becomes 2F plus 5 plus F equals 29. Right? This is Charlie plus Frank is 29. So 3F is equal to 24. Frankie read 8. So Frankie read 8, and together they read 29. Charlie read 21. Okay. All right. Kelly has 40 coins worth a total of $8.80. Some of the coins are nickels, and the rest are quarters. How many of each kind of coin does Kelly have? Okay, so I'm going to actually set up a little table here. We have 2 pieces of information. We know the number of coins and the value of the coins. So we have number and value. Okay. And our number of coins is 40. Number of coins is 40. And the value is $8.80. And if I call N number of nickels and Q number of quarters, I can set up some equations. I know that the number is N plus Q is equal to 40. And then the value, I know that every nickel is worth 5 cents. And every quarter is worth 25 cents. So here's my two equations. I really don't want to work with these decimals though. So I'm going to clear these decimals and turn this into 5N plus 25Q equals 880. So let's take a look at what that looks like. I have N plus Q is equal to 40. I have 5N plus 25Q is equal to 880. So I need to solve that now. We could solve this for N and then substitute, but I'm going to go ahead and make either N or Q's match. I think I can make N's match really easily if I divide each one of these by 5. So if I divide each one of these by 5, this equation becomes N plus 5Q. 880 divided by 5 is 176. Okay, so instead of multiplying this whole thing through by 5, I instead divided this by 5. So now N plus Q is equal to 40. I took that and just moved it down here. Now I can subtract, right? N minus N goes away. 5Q minus Q is 4Q is equal to 136. So Q is 136 divided by 4. That's 34 quarters. And remember, the original statement up here was the number of nickels plus the number of quarters is 40. So if Q is equal to 34, the number of nickels is going to be 6. And you could test that, like 35 times, or 34 quarters plus 6 nickels should end up with $8.80. And it does. I've checked it.